Welcome, fellow chemists, to the third video in the instrumental analysis series on infrared spectroscopy. In this video, you will be presented 4 practice spectra along with the various molecules that may have produced it. It is your job to choose the correct one. For you to reference, here are the various functional groups and the expected location of the peak or peaks on the spectrum. Now for the variety of carbon-hydrogen bonds. If you watched the previous video, you'll know why I included the benzene ring twice. Now, before we get to the first practice, give it an honest go with your analysis and use the reference tables. When I reveal the answer, I'm not going to show each and every bond type. Instead, I will start from the left of the spectrum and match peaks up to particular components. As they are checked, some options can be ruled out. It is possible that an answer is found without checking every peak. Now let's get to the first question. So here's the spectra along with the candidates. Pause the video and determine which molecule produced it. The peaks just below 3000 are indicative of sp3 carbon-hydrogen bonds, and the pair of peaks next door fits the aldehyde. At this stage, 2 substances can be ruled out. Option A can, as there is no evidence of hydrogens on sp2 carbons, and option D is not an aldehyde. The peak around 1700 is the carbonyl. The peak just above 1400 represents the hydrogens on sp3 carbons. Just to the right is the peak confirming that there is a CH3 or methyl group somewhere. Option C does have sp3 carbons and it is an aldehyde, but it does not contain a methyl group or CH3 anywhere, so it cannot have produced the spectrum. We can conclude that this substance is option B, butanol. Feel free to go through this analysis just like I did a moment ago. A quick glance at the options and spectrum allow us to eliminate one straight away. The absence of the very strong and broad peak on the left side means option A, which is a carboxylic acid, did not produce a spectrum. The peaks around 3100 are representative of hydrogens on sp2 carbons. Just below 1800 we find evidence of a carbonyl, which all remaining options have. The peak at 1600 when paired with the ones around 1500 indicate a benzene ring, which eliminates option D. Not much separates the remaining candidates, but there is an intense peak around 1200 which is caused by a carbon-oxygen single bond. This find eliminates option B, which means we have identified the molecule as option C, phenylacetate. If you need it, remember the third time's a charm. All 4 molecules are very similar, and this teeny peak here is indicative of hydrogens on sp2 carbons, which they all have. However, the peaks below 3000 are caused by hydrogens on sp3 carbons, which means option D is out. Given that, we're not surprised to see the peaks on either side of 1400, which confirms there are sp3 carbons, but also CH3s on the molecule. What we need to do is choose between the various alkenes. Since the peak is just above 800, this means the alkene is of the tri-substituted variety. Therefore, the molecule that made the spectrum is option A, 2-methylbutuene. As an aside, this tiny peak around 1600 is caused by the carbon-carbon double bond. And now for the fourth and final problem. The peaks just below 3400 are caused by the nitrogen-hydrogen bond. Yes, OH shows up in the same region, but those are stronger and broader than what we see here, so we can throw option A out the window. The next set of peaks are below 3000, which means there are a bunch of hydrogens on sp3 carbons. You might think this eliminates option C, but there aren't any hydrogens bonded to sp carbons in that molecule. What does allow us to toss out option C is the absence of the carbon-carbon triple bond peak around 2150. The peaks around 1400 are confirmation of the sp3 carbons and CH3 structures. Since there is a CH3 on the molecule, that means it cannot be option D. Therefore, the identity of the molecule is option B, 3-methylbutan-1-amine. We know the compound, but the reason I chose this example was the peak around 1600. This also represents the nitrogen-hydrogen bond. Where the one around 3400 was a stretching vibration, this is caused by bending. Notice it is broader and more intense than the carbon-carbon double bond that was there in the third practice. The reason for this is the nitrogen-hydrogen bond is more polar and due to the effects of hydrogen bonding. At this point, 3 videos into the IR series, you have learned to interpret spectra like this to find key components and even identify substances. In the next video, you will be presented not only with the IR, but also the mass spectrum of a compound. You must put the skills you have learned over the 7 videos of this series and identify the substance on those alone, because I will not show you any options. You can prepare by watching the previous videos, of course, and until it is posted, thank you very much for watching. Please leave any questions or requests in the comments below.